to dig through your binder and find three different things. Number 3 and number 4 from your binder. That would be the 4.1 notes we started last class. The 4.1 book assignment we started last class. And there was a sheet, the Getting to Know You sheet. So I'm going to collect the Getting to Know You sheet, so if you get that out, and give me just a second. I missed the call over here. I need to get attendance put in anyway. We don't do the passes the first 10 minutes of class, just so you know.
I just said you guys time to go during passing period.
Sorry, I'm pretty slow on attendance since I don't know names, so just be patient with me for just a second. Okay, so normally if I have you guys turn in something physical, I have a homework box over here, just a little homework tray. Sometimes I might move it over here closer to my desk. I don't want you to all get up to come turn in this one page right now, so if you would just hand me your Getting to Know You page as I come around. If you didn't finish it, you forgot about it, you can still do it and just put it in that box and get it in class if you did. Thank you. Alright, so since we tackled some of this last class, we don't have as much to try to get through today. But first thing we're going to do is finish up those notes, because we only got through about 60% of it. And then I had we do some of the book work, but there was several of the questions you didn't know what it was asking for. So once we finish the notes, I will ask you to go back and try to finish that. There was 2 handouts that you guys picked up today. Those make up handout number 5. And those, each one of those is basically a practice quiz. So I don't know if I verbalized it last class, but one thing I put on our agenda is when I know when our quizzes are going to be. So if you look back at our first slide, which you do have access to on our website, I thought our quiz was going to be on Friday, but turns out it is going to be on Monday. Give us a little bit more breathing room for this first one. So if anything, that should help out, I guess. So I have updated that on the far right there. I will always try to keep that as up to date as possible. That way, if you guys forget if there's a quiz, it's pretty quick to just check. But notice here is our first day slide. I was expecting it on the 18th, and now it's going to be the 21st. So that's how I try to communicate that with y'all, in case you don't hear me verbalize it. All right, so 4.1 notes. We did all right, so the stuff that we talked about last time was what is standard position? How do you measure positive versus negative angles? Started looking and comparing and contrasting degrees versus radians. We had this little unit conversion
that can take you from degrees to radians or radians to degrees. And then the only other part of the notes we did last time is what a coterminal angle is and how to find coterminal angles. So that should put us at complementary and supplementary, which is the same terms that you guys heard in geometry. We're just going to extend it to degrees and radians. Now, if you don't remember what complementary and supplementary mean, this is good review for ACT, because I think they do throw this on the ACT. Okay, so complementary are angles that add up to how many degrees? 90. That one's 90. And does anyone remember 90 degrees is the same as how many radians?
Pi over 2.
Very good. So you can use that unit conversion on the front page, but this is one we use a lot, so you'll memorize it eventually. Okay, so I've got a couple in degrees that we can do pretty quick, and then a couple in radians we'll have to slow down on. But degrees, what angle is complementary to 15? I agree, 75. What about 89? 1 degree. And somebody else, 91 degrees. All right, so it's a little bit of a trick. By definition, they actually have to be positive angles. So if one of them has to be negative for that to happen, we say it's not possible. Has to be 2 positive angles that add up to 90. That doesn't really come up in geometry much because I don't think y'all do negative angles. But. Okay, so this next part, I highly recommend you write this down. Well, if I'm writing it down, I expect you to write it down anyway. But what we did on these questions and how you answered them so quick, you're not going to be able to answer this one so quick. I think a few of you might be able to be creative enough or good enough with fractions or enough experience with unit circle that you might know the answer to this one. But realistically, most people can't do this yet. Bless you. So let's think about what we did on this one in our head. Bless you. So that we can apply the same logic to this one. What you did is you, in your head, you said, what can I add to 15 degrees to make it get to how many degrees? 90, because it's about complementary. And then you've just got a one-step equation. You probably didn't write that down. You could probably just do that in your head. The second one, what can we add to 89 degrees to get to 90 degrees? That's obviously 1 degree. If we apply that same logic down here, what can I add to pi over 3 radians to get not 90 degrees, because degrees and radians are 2 different things, but to get to pi over 2 radians? You need to see how that equation is the same setup, same thought process. You guys okay with me setting that up? Now, it's not finished, but at least we have something that we can just solve now. We can subtract this over. Unfortunately, we do a lot of fraction stuff the first 2 weeks of school, not just multiply and divide, also add and subtract. To add or subtract, you need to get a common denominator. So, common denominator would be over 12. And then 6 pi over 12 minus 4 pi over 12 would be 2 pi over 12, which reduces to pi over 6. So if somehow you can come up with that one without writing that out, that is great. I'm happy for you. That it's unusual. This is really the key. Force yourself to write out the equation, because then at least you can just solve the equation. What can I add to that angle to get to complementary pi over 2? And then if you solve the equation correctly, your answer should be correct. Okay, and I want you to give that a shot. So over to the right, there's 2 of them. So see what you do, or at least see where you get stuck. And I'll give you 2 minutes to try both of those. If you aren't sure, just give it your best shot. It's good for you to at least see where you may go wrong if you do go wrong. You'll still practice this a couple more times in the bookwork. But. Okay, so the first one here should have taken you a minute, but hopefully you didn't spend too much time setting this up, since it should just be the same setup as the other one. What can you add to this angle to get pi over 2? And honestly, I don't know if I could do this one in my head. I'd have to be very careful to not make a mistake. But it's not hard for me to write out what I'm trying to achieve. Then I can just subtract this over. To add or you don't have to do this for multiplying and dividing, but to add or subtract, you need a common denominator, which would be over 18. And then 9 pi over 18 minus 2 pi over 18 should leave you 7 pi over 18. Make sure that you make any corrections that you need to, and even better if you write yourself a little note about maybe where you went wrong, if something went wrong. You guys are okay with the setup and the common denominator? Okay. All right, so I could see how you could spend 2 minutes on this one easily, but the second one, I asked you to do 2. This one confuses students at first, but do it the same way. What can you add to 1 radian to get pi over 2? How do I solve this? How do I solve this for x equals? And these are not like terms, so you can't even do anything else. That's actually a quicker question, easier. It's the same thought process though. Students are usually uncomfortable with radians, not in terms of pi, but oftentimes that's actually easier work. Okay, so to just keep going with that, supplementary almost means the same thing. Supplementary means they add up to 180 degrees, but in terms of radians, that would be pi radians. So degrees we can probably do pretty quickly. Radians we probably can't do so quickly, unless you're just really good with fractions and maybe you have the unit circle visualized. So I suspect you can tell me the supplement to 80 degrees quickly is going to be what? 100. And even though that's almost instant, in your head you're saying, what can I add to 80 to get to 180, which is 100. So you could do the same thing with this one. What can I add to 120 to get to 180? What can I add to 210 to get to 180? No solution, good. Again, I'm not trying to trick you, but I'm just trying to help you see that if you're not careful, it has to be positive by definition, not possible. And even though that seems unnecessary for degrees, it helps us with radians. We can say, what could I add to pi over 4 to get to pi? Now, this one's a lot easier for me to do in my head because I know how big pi over 4 is. I know how far I have to get to pi. I can kind of visualize that's going to be 3 pi over 4. But if you can't, you've got an equation to solve. Just undo add with subtract. You got to change this to common denominators. And 4 pi over 4 minus 1 pi over 4 would leave you 3 pi over 4. Shouldn't be any harder than complementary. Okay, so I'm going pretty quickly there, so I need y'all to speak up and let me know. Is that too fast? Is there a step of that y'all want to? Okay, then take 2 minutes and see if you can get both of these right on the right. You can also kind of cheat on this first one if you're paying attention. Seemed like maybe that was a little bit too long, so I'm going to cut you off here. So what I was saying about the cheating is it's really the same as the question before it, right? If pi over 4 and 3 pi over 4 are supplementary, then 3 pi over 4 and 1 pi over 4 are supplementary. But again, it really isn't that much work to do it this way. You have to keep straight which one's complementary and which one's supplementary. You get those two switched up, you end up missing all of those. But then you have an equation that you can solve. You need common denominator. 4 pi over 4 minus 3 pi over 4 leaves behind 1 pi over 4. Okay, and then 2 radians. Radians don't have to be in terms of pi, but again, if you do it the way I suggest, and of course if you have something that feels a little bit more comfortable, you're welcome to do that. But I've been doing pre-cal for like 12 years now, so I usually know which ones are good for most students. If you force yourself to write it out like this, it's pretty obvious. You should undo the plus 2 with the minus 2. These are not like terms, so you can't combine them. Don't try to overdo it. Just quit. That's it. Pi minus 2 would be the answer to that. Yeah.
What exactly is like 2 radians? Because I always see the radians in terms of like the pi symbol. So are they on the unit circle, or is it just?
They are. They're just not spots that we memorize. So, like right here, we know this is 0 radians, right? We know all the way around is how many radians? 2 pi. You need to memorize that one. Because if you know all the way around to 2 pi, halfway around is half of that, pi. And what is pi as a decimal?
0.3.14.
There you go. So from here to here is about 3.14 radians. So roughly, this is about 1 radian. Roughly from here to, if I try to double that, that approximately is what 2 radians looks like. If I try to add that angle again, roughly that's what 3 radians looks like, because pi is just a tiny bit more than that. So you'll have some questions in your assignment where it'll ask you to like sketch, and it's just an estimate. And then of course, if you want to go all the way around, 2 pi is like 2 times 3.14. So to think of this as a decimal is about 6.28. Sometimes that's helpful to kind of know roughly where it lands. It's a good question. Okay, other questions on that one? Because this is all I've got on the notes for that piece. Okay, next to the last part of our notes then is we need to talk about something called degrees, minutes, and seconds, which some of you guys started to see in the book assignment, and I told you just to skip those. But these will just pop up here and there. Even in March, That'll probably be a book assignment that has 1 or 2 questions of something completely different, but you have to be able to deal with the degrees, minutes, and seconds before you can move forward. So this stuff comes up naturally a lot because this is how latitude and longitude is written in degrees, minutes, and seconds, and because that's how they navigate on big maps. That ends up being how ships and airplanes that are doing long travel have to navigate, because obviously you can't just do straight past. You have to go around the curvature of the Earth. So something that is in degrees, minutes, and seconds could look something like this. It could be 5 degrees, 17 minutes, and 34 seconds. I'm just making up numbers, but that's how it reads. You've got degrees, minutes has 1 little tick mark, and seconds has 2 tick marks. The problem is this is kind of hard to work with. So we need to know how to change this to what's called a decimal degree. A decimal degree is where you have a degree that's in terms of a decimal. Again, I'm just making up numbers to show you what it looks like. Now, some of the stuff in this notes are going to be optional. I kind of talked about if you really like to explore with your calculator, somewhere in your calculator it does have minute and second symbols. I don't bother memorizing that because I think it's good to know what those mean anyway. And if you need to borrow one of my calculators, you can here in a little bit. I don't want you to get up and do it right now, but I've got some over here, and you'll need these for the book assignment for some of these. So we will ask you to change this degrees, minutes, and seconds into a decimal. So what you're going to do is, if it's 60 degrees, you've got 60 full degrees. A minute is a 60th of a degree. So this made-up problem has 34 of them, because there's 60 minutes in an hour. And then seconds are over, well, how many seconds are in an hour? $3,600. And so if you know a minute is a 60th of a degree and a second is a 3600th of a degree, you literally just throw it in the calculator just the way I wrote it. You don't have to do that right now. I'm doing it for us. And your calculator will tell you that's about 60.582 degrees, which makes sense. We had 60 full degrees plus a little bit more. 60 degrees plus a little bit more. This is the only way I will refer to it in class because it reinforces what a minute is and what a second is, and so you'll, through repetition, that will stick eventually. If you really, really just love calculators and technology and stuff, if you want to dig through the menus, you can try to find the minute and second symbol. But okay, we also go the other direction, and our calculator can do this for us. It's got a arrow DMS command, which just means change to degrees, minutes, and seconds. So when we ask you to change 60 degrees, 60.54 degrees, what I want to type in my calculator is 60.54, and then this command, arrow DMS. So I will show you what that looks like. All right, like all the stuff in these calculators, if you dig through some of these menus, you may find where arrow DMS is. I don't mess with that. I just do the catalog because the catalog has everything. So second 0 gets you to the catalog. It takes forever to scroll down to the D's. So if you just hit the button with D on it, it will jump to at least the D's. And alphabetical. There we go. Hit enter to throw it on the home screen, and then enter, and then your calculator knows what you're doing with that. You're taking that decimal degree, and then that's your answer for your notes there. 60.54 degrees is the same thing as 60 minutes, or I'm sorry, 60 degrees, 32 minutes, and 24 seconds. So your calculator does all the heavy lifting there. You just have to know that it can do it, and you have to practice it a few times to know where to find it in your calculator. But again, catalog has everything. And then below that, I talked kind of about, or I typed out kind of how you can do some guess and check to do that. But to do that, you would need a calculator anyway. So it's, you know, if you If you really want to explore that, go for it, but most people don't care about that, so I'm going to skip it. All right, which leaves us to the last piece. So I think when we did the vocab check last time, question 5 I told you to throw off, because that's over linear speed and angular speed, which we used to also do. But we do still keep one of the small applications in here, and that is arc length. All right, so do you guys remember back from geometry what it means for the distance all the way around a circle? Okay, circumference, and there was a formula for that. Arc length is if you just want to know the distance around part of the circle. And we use the letter S for this. This is about as easy as a formula as you're ever going to get, but there's one catch to it. The formula says arc length S is equal to R times theta, but the catch is, and you need to highlight this in your work, I bolded it in your notes, this formula only works if theta is in terms of radians. So obviously I had no input into our textbook and how it was designed, but it's always been my theory that they throw this in the first section so that you can see at least one example of why radians are necessary. It's not just something that some mathematician came up with and made everybody learn. Like, some stuff only works in radians. So for this example, I'm just going to steal this picture. Let's say that the radius length was 2 inches. And let's say that the central angle, so that's the angle at the center of the circle, was 45 degrees. You're almost ready to compute the arc length. You're going to say S is equal to R times theta. And if you of you are going to do this on our quiz next week, and you're going to say that the arc length is 90 inches, but why is that not correct? The formula only works in radians. So what you have to do before that is you have to convert 45, like we did last class, to pi over 4. You can just trust me, that's what it comes out to be. So you end up with pi over 2 inches. This is like 1.5 inches, way different than 90 inches. You have to be in radians. But otherwise it's pretty easy. Okay, and it can do other things. So we got one more example here. If we know the radius is 75 feet, and let's say we know the arc length is 60 feet, we can also use this formula to figure out how big that angle has to be. How big does that angle have to open up to be? So this formula would still be used because it's incorporating arc length, radius, and central angle. Trust me for just a second that you should keep up with units. If we plug in 60 feet for arc length, 75 feet for radius, you get that. And then how do you go about solving this? Okay, undo times with divide. Again, keep up with your units for a second. Let's see, 60 over 75 I think reduces to 4/5, but I'm going to use a calculator just to check. It does. Now, I said keep up with the units, and this is trying to show you from a different angle something else we talked about last class. What happens when we do feet divided by feet? Well, like any fraction thing, these are going to cancel out, right? Those reduce. So what are my units now? Is my unit still feet? Very good, radians. So radians are considered the blank unit. Anytime you do some work, if all of your units go away, you are left with a radian. Likewise, just a few questions ago, we said 2, I think. If it didn't say 2 degrees, that implies 2 radians. You don't have to say radians for it to mean radians. If all of your units go away, your answer is now in radians. So, easy formula to memorize, pretty easy formula to execute. and solve, but make sure you know it only works in radians. You have to convert degrees to radians if that's one of the things that give it to you. All right, anything jumps out at you on that one before we move on? Just give everyone a quick chance. Okay, then if I was you, I would keep that out. But so on your book assignment from last class, there was certain couple questions you had to skip because they were about complementary, supplementary. You now have some notes to look at and to give those a shot, so please do. A couple of those were about degrees, minutes, and seconds. Now that we've talked about those, you can give those a shot. A couple are about arc length that we just did, so you can give those a shot. And by the time you do those, you're going to be pretty close to finished with the book work. So that is going to be the next thing. And I'm going to give you all a few minutes head start, and then I will come around and help out. And if I get the same question from multiple people, I'll pause you and we'll do it on the board. So,
Can I ask the bathroom?
yes. You either need to leave your phone there or put your name on the board, and then when you bring in the pass back, you can take your phone back or take your name off the board. Now, for those of you that got pretty far through the book assignment, as you finish, if you want to go ahead and start one of those practice quizzes so you don't have to do that for homework. In my first period today, most of the class was able to do that, and I would even say maybe the majority of them even finished it. Your handout today is two worksheets. You only have to do one of them. Ideally, the one that's not 4.1b, just the 4.1. But that's basically a practice quiz. We don't give you a practice quiz every section this year, but it's kind of needed on the first one because it's a lot of information, and you guys are just coming back from summer break and all that kind of stuff. So,
Do you have extra sheets of paper?
I do. Anybody else want some extra paper?
Thank you.
Okay, now I try. Try not to interrupt y'all too much when I want you to actually stop and practice. I think my internet is down over here, so I can't show you physically. But remember the class website I had you bookmark last class has every one of these book questions worked out. So I don't feel like you need to use these during class. But like if I'm busy helping some other people and you don't want to wait for some help, you're welcome to pull those up on your Chromebook. Of course, if your sound's off, I don't want you to play the sound out loud. That's also a good resource for the even questions. There's no way for you to know if you did question 28 correct because the back of the book only puts the odd answers. But if you want to pull up my number 28 video, skip to the end. If you got the right answer, great. If you didn't, you might start it over and actually watch it. But maybe even more important than all of that, because you don't really need to do that during class, but you're welcome to. For those of you that do the practice quiz while you're in class, you need to check your answers to it, and the answer solution is linked on that website. So don't just work it and not know which ones were correct. Complementary, supplementary have to be positive. So again, I will come around and help clear up some of the stuff that pops up, but I want you to get a handful more questions under your belt before I start bugging you. that if you guys need to borrow one of my calculators, when you get to that point, they're up here by my desk. So feel free to help yourself. In general, if you know that you're going to borrow one of my calculators for class, just grab it at the start of class and then put it back at the end of class. So as I come around, if you've got something you want me to look at and give you some guidance on, just call me over. Okay, so there's no booklet. When you do that practice quiz, obviously try to do it without your notes and stuff just to see how it goes and then check the answers. All of them should be pretty straightforward except the last one's kind of challenging, but we'll worry about it next time. You should still give it a shot. Anything over here yet? Well, I would go to catalog because I know everything's in catalog. And you have to put the angle in first. But you can just make up something. And you can just roll all the way down to the D's, which is going to take a while. Or you can hit this button and go to D's. And then just keep going. So doing this. Hit enter once, and then put on the home screen, and then enter once for it to do the rest of the work. Make sure that you like write that down or something somewhere so you remember. This radius is here. The way that you're supposed to know this is a radian is it doesn't say radians are like, it doesn't say the number. Okay, so not 180, if we're doing radius, 1.5. So you should be trying to figure out what can you add to that. You can find. Just like this. seems like there's a few more of you than I expected to already be on the practice quiz, which is fine. That's great. But do keep in mind as a practice quiz, after you finish, or try to do it without your note, without your neighbor, all that kind of stuff, because it's, honor system, it's not a real quiz anyway. But when you check the answers with my website that you bookmarked, questions that you missed, you really should probably circle those questions because those are the ones you should go back and review. You don't have to, but you're encouraged to use highlighters if it helps. I've got a big tub of highlighters by our handouts. So anytime you ever want a highlighter or three, just like everything else in here, just grab them at the start of class and put them back at the end. I'd really rather you do this one before Friday, and then I'll give you more class time on Friday to do that.
And then for this
Now,
one.
if you have time, you might as well move on, but.
But for the, what are the things we can check?
Okay, so this is number 5 in your binder. So you could download another copy if you really wanted one, and then write the solutions. So if you click that,
I put them in the middle of the just in here back.
it should be downloading automatically. Can you go up here to download? Is that not? Okay, let me check the link then.
I think it may have been an error on my part. If you want to refresh that page, put a new link to it. So click it. Should just. Refreshed because it's working on mine. Double check your downloads. Make sure it's not just going straight to your downloads and not in the pop up. Still no. Okay. I'll wait and see if other people are having an issue. The only other thing I know to try right now would be either restarting your Chromebook or maybe trying to pull it up on your phone and see if that has the same issue. But I'll ask other people when they're getting there.
Is this?
Oh, did they get it? Yeah.
I don't know where to put it.
I could get just like points. They could be seconds.
That's your wallpaper? That's your phone was messed up for a second.
Yeah.
Like you're pressing on the screen too hard. Over here. You have the bookwork pen already?
It's.
Just double check.
those of you that are already on the practice quiz, first 9 questions should be pretty straightforward, just like we did in the notes, just like we did in the book. And then question 10 is a little bit, you gotta be a little bit creative to try to see how to put these pieces together, so. I still want you to try it, but don't feel like you're behind if you get stuck on number 10. We will talk about it together next class since we have an extra day.
I've got the.
Yeah, she comes back with the pass. Just move my phone up there, so I'll put your name on the board, and then hit your name on the board. So again, when you finish with all of it, you need to check your entries on that. Got this nice fancy calculator, you'd rather use that one?
Yeah, this is easier.
No, okay.
accomplish.
Bless you.
Okay, I'm gonna come around a few more times, so just like before, feel free to call me over if you see something I can help with.
It's probably not that. Is there somewhere else on your computer outside of this to look at your downloads? It's probably just saved a bunch over the years.
Yeah, sure.
Like if you can see. Yeah, you're showing folder. And then see, so there's all the stuff you downloaded over the years.
So I should delete them.
Well, just delete the ones you're not using now.
Okay.
And you might be able to scroll all the way up, you might find some, it's just really big in size. No, maybe not. If you know you don't need some of those, just delete them, you're just out of space, but that's gonna give you problems in other classes anyway, so. How does that one go? Yes. Disagrees, we have to say. What about 10? How are you doing that? Oh, okay. You should still try it. It's not like it's any, it's trying to use some of these other skills, but it's not telling you which ones to do, so. Should at least try it before trying. know where to check the answers when you're done?
Yeah, I don't know.
Okay, what's wrong with that?
Yes, these are David. Page 97, please.
Write it out. So I'm just trying to go straight to the answer. Make yourself write this first. And what was this? The article. And articles. Okay, so if you're trying to solve for theta, you should be dividing both sides by 3. Is that what you have? But that way you're not guessing if it's set up correctly. Oh, you did have it? Oh, you switched it. Did you do the other one already?
So you might help me with the 26.
Okay, what quadrant would this land in?
Yeah. I just need help with use the
Okay.
showed us the.
Well, that changes its degrees, minutes, and seconds. This is already in degrees and minutes. There's just no seconds. If you wanna change this back to a decimal, you're gonna have to do 132 plus 50 over 60. So go ahead and-
Okay, just
It's gonna be basically 132 though. Okay. hit enter.
I 32. Parentheses there.
With the order of operations, it'll do it correctly, but yes, parentheses is never a bad idea.
32. But it gives.
And then technically negative though, because there's a negative outcome. So if you know, you have to know that all angles start here, standard position, negative's going this way.
So it's quadrant 3.
Yeah. In that case, the minutes there just did almost nothing, so, but sometimes it matters. Mhm. Well, if you tell it to do DMS, you're asking it to change it into degrees, minutes, and seconds. This is already in degrees, minutes, and seconds. If you want that as a decimal, you gotta do it the other way. It's 39 plus 47 over 60 plus 52 over 3600, and that'll change it to a decimal for you, which is what we do. Hang on to it for now. You got your name on there though? Okay. I just haven't collected it. Yeah, guys, when it comes time to turn stuff in, I'll make it very obvious. I'll always announce it, or almost always it'll be in Google Classroom. I will verbally announce it at the start of class, and I put it on the agenda. So if it's not on the agenda and I didn't verbally announce it, y'all don't have to worry about turning anything in yet. Just make sure you have it for when I ask for it. Finish with number 10 yet? Okay, write formula. Do this, and converted that. You need to convert it, you convert it correctly. 3 goes in the 15 5 times. Yep, that all looks good. Except radians are blank units, so you don't have to write it. And then technically you have inches still, so you should probably, this is a length, so you should still say this, that many inches. So that's an exact answer. If that really bugs you, you should look at it as a decimal. It's almost 3 inches. Okay. check your work yet? Okay. That's close. I don't know if that's right, but that's close. If it's not right, it's close. Once you guys check your answers to the practice quiz does have 2 extra questions on the bottom of the back page, and those are things you guys are not responsible for. So you can just ignore those part of the solutions. There's no question 11 or 12. So don't freak out when you see those. That's the stuff we cut out to make it a little bit easier on y'all at the start of the year. Have you tried restarting your Chromebook?
No.
You might try that. I'll also just email this one to you real quick so that you can at least move on with the math stuff.
Okay, thanks.
I emailed it to you, but it might be the same issue. I'm not sure how that works on your side. But you can also try it on your phone if you have your phone with you. Or what, I don't know. I just don't know how the Chromebooks work, you know,
Yeah.
so.
If it says leave your answer as a multiple pi, or no multiply in, if it says round, you should times by pi, mix it all up. It depends. If the directions say leave your answer in front of pi, if it's a multiple pi, you should not multiply it, leave it in your answer. If it says round, then you should actually multiply it and just get it all in one place. I understand.
I need some water. Yeah. Just take, either leave your phone or put your name on the board so you can back. Are you close on that one? Good job. That's pretty good without any hints.
Is this right?
No idea what that.
Maybe you can make it darker if you do that. Second up makes it darker. It is just darker. So let's see, you go from radians to degrees, you would want to multiply by 180 over pi. Pi's are gonna cancel out anyway. 1,000, yep, that's good. Thank you.
Yeah, I don't put everything in Google Classroom, it's way too much. That website that I, did you bookmark the website? You had the handouts from last time?
Yes, I can, that's all it was. Thank you.
Yeah, so if you just scroll down to slide number 5, and it'll be download a new copy of the solution, just click the solution link and it should just download. We are down to about 4 minutes here, so I just want to be very clear with what you need, where you need to be next class. So you should have the bookwork finished. as I went around. That was the top priority. If there were some of those you did not finish and you need some help on them, remember the website that I had you bookmark last class. My website has all of those worked out as individual videos, so use that to help you. You guys picked up 2 handouts today. Both of those make up number 5. You need to do one of those 2. You don't have to do both of those before Friday. One of them's called 4.1 worksheet and one's called 4.1 worksheet B. You don't have to do the B one until Friday. But please do the other one. Try it without your notes. Try it without some help. Check your answers with the website. See how you're doing. And then that way when I see you on Friday, you know exactly what you're dealing with. And it'll be easy to get you up to speed. But in the meantime, if you borrow the calculator, you need to start bringing that back. The books you're welcome to put back now or on your way out, but don't line up.